Hello guys, welcome to Sumo Code. So today we are going to learn about what is RAG, Retrieval-Augmented Generation. We'll also be building a full-fledged RAG application which will be using a vector database along with OpenAI's chat completion APIs. So what is RAG? RAG is nothing but an AI framework that combines the power of an information retrieval system, which is nothing but a database, with the generative AIs, which are LLMs. So what RAG is? RAG is a combination of a database which is nothing but an retrieval system along with an LLM. So this is what RAG is. So now what RAGs helps us in achieving? It improves or enhances the power of the searches that you can do using the LLMs. Searching power is improved highly. So how are they done? Because LLMs have some limitations. So what are the limitations of these LLMs? LLMs are trained on outdated data. The data on which they are trained on are not recent. They are also trained on public data. So this is also one more drawback. Third one is that there is a limit on the tokens that you can send in one request to these LLMs. So limited context is also there. Like for ChatGPT 4o models, there is a limit of 128k tokens that you can send in one request. So these are the three main problems associated with an LLM. So RAG is going to help us in overcoming all these problems using an information retrieval system, which is going to be our vector database. So let's look at how it happens. So here all the problems related to the LLMs. So what we can do is, in the context of the prompt that we are going to send to the LLM or the query, we pass in the relevant information related to the query. So consider if we have a big book, like consider 1000 pages are there in a book, and we wanted to perform a search on this book. And that book has been launched recently, and the LLM do not have any information on that. Then how this will help? We, in the context of the query that we are going to pass to the LLM, we pass in only the pages related to which our question is there. So in this way, the information that would be passed into the query context or the prompt would be latest one, and also will be within the context limit of the LLM. So if we pass in all these information to the LLM, it will have a very much high chance that it will give us the correct output. So how can we pass only some of the pages which are related to our query? So that's where vector database comes into action. And using this vector database, we are going to perform the RAG. So now let's look at the RAG architecture and how this retrieval of relevant pages or the information comes in. So to do that, in RAG architecture, we are going to use a vector database. So now, to perform search on a book which is very much recent or your private documents, what we have to first do is store it in a database. And then that database is our vector database. Now how we are going to store is, we are going to chunk it into smaller parts. Those chunk can be one page of the book, or smaller parts like paragraph. One paragraph would be one chunk. So this chunking strategy depends on your use case to use case. So you are going to chunk it into smaller parts and are going to store it in the vector database of yours. There are many vector database in the market, such as Weaviate, Pinecone, Chroma. So all those are there. So now our first step is done, which is storage. Storing of the document has been done. Now we are going to query. So whenever we are going to do some query, along with the query, we are going to find the relevant information in this vector database. So we are going to only find the chunks which are related to our query. So this is our stage of information retrieval. So we get those chunks, we combine it with our query, pass it to our LLM. So here you can see that if we use such a system, then there are a very much high chance that we are going to get a good output, and it will resolve all these problems of an LLM as well, which are outdated, public data only, limited context. So the RAG helps us in overcoming all this. If you don't know what vector database is, I'm going to just go through a very quick description or explanation of vector database. If you want to know a bit more detailed about it, I've made a video on my channel. You can go and look at that as well. So what vector databases are? Vector databases store vectors. What are vectors? Vectors are just list of numbers representing something in a multidimensional space. What they represent? They can represent anything like text, image, audio, or video. Videos are just series of images only. So anything they can represent. Now, what is so special about vectors that can help us in finding those similar images or text? So how can that happen? Vectors of similar text, semantic vectors of similar semantic meaning text or images are created in such a way that when they are plotted in a multi-dimensional space, they are located to each other if they are similar. So now if you query something like find similar to this keyword or this query, it will search its nearer parts and will find the nearest vectors to it, and they will give its result, which will help us in finding the semantically similar queries to the current query. So how are these vectors created in such a way that similar vectors are stored similar to each other? They are done using this embedding model. What is an embedding model? Embedding model is a neural network which is trained in such a way that if you pass text or any data to it, it will convert it into the vectors, and similar text or similar data as vectors are stored together. So using these embedding models, you are going to create vectors. Now what happens in the vector database is that if this is my vector database, data is passed in this vector database, data would be automatically converted using an embedding model that you are going to configure in this vector database. So those data would be converted into the vectors using this embedding model that you have passed, and then would be stored in the database. So this is what happens in a vector database. Now, what are the operations that you can perform in a vector database? You can do similarity search, which is nothing but finding similar vectors. You can do keyword research as well, which is nothing but finding the most occurrences of a keyword in a chunk of text, which is also known as BM25. So you can do that as well. You can also perform hybrid search as well, which is a combination of vector and keyword search. Also, not just for text, you can also do all these things for images as well, or any other kind of data as well. Now we are going to go into the code and let's look at what we are going to build today. So today the RAG application that we are going to build is that we are going to perform certain searches over the most recent research papers that have been published over the arXiv website. So these are some of the research papers. So what we are going to do is download a bunch of them and perform search over them. And because these have been just published like on the last week or so, ChatGPT won't be having any information about that. So let's see if ChatGPT has it or not, if we are not using the web search feature of the ChatGPT. So this is the prompt that I have. It asks about asks for a summary for this theoretical benefit and limitations of diffusion language models, which is written by these guys. And also do not use the web search. Let's see what ChatGPT gives us the answer. So as you can see, it says that I don't have direct access to this specific paper, but it is public. But because it was a recently released research paper, so that's why ChatGPT does not have information about that. And anything that now it is giving is just a hallucination or something that he is making up. So now let's build a RAG application around that. So for our application, we are going to use Fast API as for our web server, and we will be creating some APIs for vectorizing our documents and then performing search over them. We will be using Weaviate as our vector database, and we will be using OpenAI for doing the inference calls. So to start with, I will be first launching my Weaviate database first. So for that, I will be creating a directory which will have all my Weaviate deployment code. So I will be using Docker for deployment. So if you go to the Weaviate's documentation page, and if you go to the installation section and go to the Docker, so it has the Docker Compose file that you can directly copy and use to make Weaviate run on your local. So this is the Docker Compose file that you can use. I already have one, so let me create one. So this is the Docker Compose file which will be launching the Weaviate vector database on our local system. So here in this Docker Compose file of the Weaviate, the most important thing is this enable module section where we provide which embedding model that we want to enable. Here we are using the embedding model which will convert text to vector of OpenAI. So these models would be of OpenAI. So if you want to use embedding model provided by someone else, so like Hugging Face or Cohere, so anything like that. So for that, you can use these different modules. So you can add those by comma separated like text to vec, Hugging Face, generative Cohere. So all these things you can add in this enable module section. So if you want to know more about this, you can just check it in the Weaviate documentation site. So now let's go back into the code. So let's try to start our Weaviate on our Docker. So for that, let's try to start this Docker compose file. Docker compose up -f Weaviate Docker compose.time. So using this command, the container has been created. It should be up. So here, as you can see, our Weaviate database service has started. So now let's start our code. So first we would be creating one directory app which will have all our fast API code. So first let me create one requirement.txt file which will have all our libraries. So here so first we need fast API and UV cron. So let's install these. Sorry, the file name was different. So let's start this. So these have been installed. Now let me create my main file. So here let's create our fast API server. Let's import it from fast API, import fast API. So fast API has been imported. Let's create a API just for testing if our server is running or not. So app.get. So this is our API to test it out. Let's run it. So I've used this command uvcron app.main.app because my main file is inside the app folder. So our server has started at port 8080. Let's see if it's running or not. So as you can see, our server is running. So before starting off, let me add some logging configurations first. So let me create this file. So here I have just added this normal logging configuration that you can find anywhere. So this is done. Also, to also now in our rag application, what we need is one API for vectorizing our data. So any data that we want to vectorize, so using this API we would be vectorizing or storing all our data. And the other API that we want is the search API to perform searches over the data that we have stored. So let's create this vectorize API first. Now to vectorize our data, what I'm going to do is I will be having one folder, my CMS folder, where and everything that I want to vectorize would be stored here. So all the research papers that I want to vectorize would be stored in this CMS folder. Let's add all those PDFs here. So here in my downloads, I have downloaded all these PDFs, as you can see. So let me just copy it here. So here I have copied all the most recent research papers that have been published in past few weeks. So now let's start vectorizing. So to start vectorizing, let me create one folder just for all the logic related to vectorize. So in this vectorize method, we would first try to get all the files which is present in our CMS folder. So let's do it first. So CMS path equal to So here in this code, what I've done is I have fetched all the files which are present in this CMS path. So since now we have all the files, what we are going to do is we are going to loop over each of these files and creating a chunk from this file. What will be our chunk size? Our chunk size would be each page of the PDF file. So each page is our chunk and we would be storing these chunks into our vector database with its proper page number and file from which it has come from. So let's do that. Also, to read the text from these PDF files, we would be needing one external library, which is PyM PDF. So let's install it as well. So here we have installed PyMU PDF as well. So let's start creating chunk of our files. So for file in now here we have got an instance of our PDF file in this doc variable using the fits. Fits come from PyMU PDF library. So here using this get text method, we have got all the text from each page of the PDF document that we have started looping over. So now let's create one array which will have all the pages. So let's create one content dot append. So here what I've done is I've created one dictionary which will have the page number of the PDF name, and what data it has, so that we are able to identify from where this data is coming from while searching. So now let's test it out whether we are getting the data from these files or not. So let's add one logger here. So let's try to run it and see if this works or not. Also, let's call it in our vectorize method. So now let's run it, and let's run our API. So it is giving some error. Let's okay. I think it's fixed now. Let's test it again. So it has worked. So let's see what this data is. Okay, this because I have added so many files. So here, page number 0, file name is there, data is there. So let's see how many files are there. So as you can see, all these objects are there in our content array. So now we have got the chunks of the data. Now what we have to do is just store it in our Weaviate vector database. So now let's write our code to store the content in our Weaviate database. So for this, let me create one folder, Weaviate store. So here in this file, what we are going to do is write our all configuration for connecting to the Weaviate database, creating connections, inserting the data into the vector database, and also searching logic as well. So let's create that. So to know how to configure our Weaviate data store, we will be going through the Weaviate documentation. So now let's see how we are going to configure. So if you come to this documentation page of Weaviate in the local instances, you can connect using this command directly. So what we are going to do in our file is that we would be creating one class, Weaviate client. Mhm. So let me write all the code for this for the configuration of Weaviate. Also, to use Weaviate, we have to use its Python library to do it. So let's install the Weaviate client now. So let's install the Weaviate client. So we have installed our Weaviate client. So what I have done here is that we have created this Weaviate class to get the instance of the Weaviate whenever we want to insert or search in the Weaviate database. So here what I've done, we have created one collection. So Weaviate has this concept of collections. It is similar to the tables. The name of our table or the collection is documents, where we are going to store our chunks of the PDF. So here this code Weaviate.connect to local would connect to our local database, local Weaviate database that have been started. So here this configuration, we have to provide the OpenAI key here because we are going to use an embedding model, which is text embedding 3 large, which is provided by the OpenAI. And because it's not free and because it's of OpenAI, and under the hood, Weaviate would make a API call to the OpenAI to convert the text that we are going to store into the vectors using this text embedding 3 large embedding model. So to that, we have to provide an OpenAI key to that. So that's why this configuration is here. Now here in this for loop, what we have done is whenever we are trying to initialize our Weaviate object, we would be creating our collection. So we would be just creating our table. So if it's not already present in the client collections, we would be creating it, and we would be providing this vectorizer config to it, which is nothing but the embedding model which we want to use. If you want to use some other embedding model, consider like of some Hugging Face provided by Hugging Face or something else. For that, all the configurations are already present in this documentation. So here, if you go under the model provider integrations, you can see all the providers that Weaviate supports, like Hugging Face is there, Mistral is there, OpenAI is there. So if you want go under this, you can see what the configuration you have to set. So here, when you are trying to get one instance of the Weaviate client, here you have to pass the Hugging Face API key, and in the when you create a collection, you have to pass this property here, which is text to vec Hugging Face. Currently we have text to vec OpenAI. So all these minor configuration changes you have to done while using some other embedding model of your choice. So now this is done. So now our Weaviate store is set up and we can also connect to it. Let's first create an environment configuration file and add our OpenAI key there. And using the .env package, we are going to fetch the properties from the env file and load it into our code. So let's do it. So here we have created this file. So let's add our .env package and install it. So it's installed. Now let's create one config file which will load our configs. So here using this load.env method, we are going to load our environment variables, which is OpenAI key, which we can add it into our Weaviate store now. So now this has also been present now. Now let's add our code for insertion and search process. So let's create a couple of methods, self, data that we want to insert, and collection where we want to store it. So this will be a list, this will be a collection. So now to know how to insert the data into the Weaviate data store, we will again go to the Weaviate documentation and let's see how it happens. So here first we have to fetch the collection, as you can see, and then we have to insert it. There is also batch. So if we want to add large number of data in batches to our vector store, then this batch method is already there, which we can use to add a large number of objects in a batching way properly. So let's use it. So here we have added this code which will do the batch insertion. So here we have created this batch object, and we are going to use its add object method to loop over all the data that we want to insert in. And inside the properties field, we are going to provide it, and we are just logging it. We would also be checking if something has failed in this batch insertion. If it has failed, it will log out. So that's how insertion is done. So let's use this insertion in our Vectorize code now. So let's create our Weaviate client here. So we have got this Weaviate client. Let's add data to this Weaviate client dot. So here we have added this. Let's add a logger as well. So here we have created this Weaviate client object, and then we are calling its insert method, which we have just created, and passing our data and the collection name to it. So it will insert the data to the Weaviate client in chunks. So now let's test our application and see if the data is getting vectorized or not. So now let's run our application. So application is started. Now let's run our API. So here the vectorization process is started. And let's see till our logger vectorization complete is uh, printed on. So now let's wait till our vectorization complete logger gets printed. Okay, now as you can see, the vectorization is completed. There are no errors as such. There is one warning. So you can actually have just not closed the connection. So because of that, memory leaks can happen. So let's fix that. So here we are now closing the connection as well. So this will fix that memory leakage issue as well. So now, since our insertion of the documents are done to our vector database, so the next part is to perform the search operation. So in search, what is going to happen is the user is going to give his search query. We are going to combine this search query with the documents which are related to that search query, which are found in this vector database. So query plus the relevant documents found in this vector database, we are going to send it to the LLM or the OpenAI for the inference. So let's start doing that. For the first thing that we are going to do is create our search function to find similar documents from the vector database. To do that, we will go to the Weaviate's documentation. So here, as you can see, there are a few types of searches that you can perform. First one is vector similarity search that we are going to do, which will help us in finding the nearest vectors, which means that we can get the similar meaning data from the vector database. Another one is image search, which is nothing but to find the similar images, which also uses the vector similarity only. Another one is keyword search, which means that the most frequently occurring word in a particular chunk of object would be returned. So based on the most frequency occurring, this keyword search is done. Then there is hybrid search, which is a combination of vector and the keyword search. We want to find is the similar text related to our query. So for that, we are going to do vector similarity search. And how to do is we have to just get the collection, then call the near text method on this collection. So let's do that. So now let's create our search method in this Weaviate client of ours. So this search method would have two parameters. One is the query, user query, and the collection name, which is also going to be the string. Let's get our client, Weaviate client. So here we have created our search method. What it does, it gets the collection, and then we are going to perform the near text method on this collection, which helps us in finding the similar data related to our query. In the parameters of this method, we are sending the query, which is the actual query of the user. Then the most important thing is the distance. What this distance means is that all the vectors which are closer to each other at a zero point 0.7 distance will be fetched out of this query. Means at least they have to be 0.7 distance closer to each other. Then only they are going to get fetched. Another one is the limit, which is just max 10 documents or the 10 chunks of the data would be retrieved. Then the last one is the metadata. Now, since we can find the similar data from our vector database, let's create our search API, using which we will be doing the RAG. Now let's create our search API using which we are going to perform the RAG. So let's do it. So let's create a search API. It will be a post API. It will have a request body, which will be having one field of type query. Now we are going to create our search method, which will be having all our logic for the RAG. So let's create that. So now in this search method, what we are going to do is RAG. What is RAG? It combines the power of GenAI with the information retrieved from a vector database or an information retrieval system, which is our vector database. So here, what we are going to first do is get the relevant documents from the Weaviate. So let's do it. So let's create a Weaviate client. Now get relevant docs. Now, since we have our relevant docs as well, we are going to create a common prompt, which will be with the combination of the user query and the relevant docs. So let's create that. So this is our prompt that combines the user query as well as the relevant docs. The prompt also says that in the response, mention the file source from which you have found this information. So using this, we can also validate the information as well and find the source of it. Now, since we have the prompt, what next we are going to do is perform the inference using OpenAI. So to do this, we are going to first install the OpenAI library. So let's do that. So here I have added the OpenAI. Let's install it. It's added. Let's use it. Now, since our OpenAI library is installed, let's perform inference. So here, what I have done is I've added the inference code using the OpenAI's library. So it calls the chat completion API, where we are just passing the system message and our user message, which is the prompt, which is a combination of the user query and the relevant docs. And after which we are just sending our response back. So now let's test our RAG application in this search API. So let's test it out. So now our application is running. So now in our search query, let's perform some search. So what did we ask here? So let's pass that in. So here I am passing the same query that I earlier passed to the chat GPT. So our query is running. Let's see what response we get. So here we have gotten a lot of response, and as you can see, the information was found from the document. This, what's this document? Let's see. If we open it from our CMS, which one is 9622? So this one is that document. Let's try to open it. If I open it, yeah, as you can see, this is the same. So this is the same research paper for which we were querying. So let's now also ask some more question related to this. So let's ask for some conclusion and see if it gives us this conclusion or not. So what's the so now let's ask the conclusion. Here you can say that it has given us the conclusion, and it says on the page 7 of this file it should be present. So because our indexing was zero based, this page is eighth one, which is the same one. What's the conclusion? The research paper it concludes that MDMs offer different levels of efficiency and accuracy. So now if we compare this conclusion with this output conclusion, they are actually both the same only. It is just a refined version of the thing that is mentioned in the research paper. So using RAG, as you can see here, you can perform searches over your private data or the documents on which the LLM has not been trained, or you can also manage your context size because this LLMs has a limit on that. So this is how you can do all these things. Some improvements can also be made, like while creating this prompt, you can also add a check whether your prompt is getting bigger than the context of this model or not. So all these checks you can add. You can also do more optimization in the vector database. Like if you are this embedding model is a general purpose embedding model which can convert a text to vector in a generalized way, but there are some embedding models which are particular to some particular use case, like for law or medical purposes. So if your use case revolves around them, you can use those embedding models as well. Those are openly available on Hugging Face or other platforms, so you can use those as well. So this is all about RAG. This was a fully functional working example of how RAG works. If you have any doubts, please write it down in the comments. I will try my best to answer them. If you like this video, please give it a thumbs up. And thanks for watching. Bye.